Hey everyone! This lesson is designed to help tie together all of our talk about acids and bases with some of the work that we did during our solutions unit when we talked about electrolytes. What we're going to do here is kind of generalize our definition of what an electrolyte was. And if you remember, an electrolyte was something that when it dissolved in water created mobile ions so that it could conduct electricity. And we looked mainly at ionic examples of that, like NaCl we saw on table F would be soluble in water, so it must be able to break apart and form those mobile ions that the electricity needs to be able to flow. But what we now have looked at are two other types of substances that can break apart in water and form ions. We've seen acids like HCl produce H plus when they're in water, and also the chlorine ion as its counterpart. We've seen bases like NaOH break apart into the sodium ion and the hydroxide ion that defines bases. And of course, yes, we've seen things like NaCl previously dissolve to form their positive and negative ions in water. What all three of these things are doing is showing us that electrolytes really have three forms. They can be acids, they can be bases, or they can be salts. So if you're defining an acid as an electrolyte, just in a Regents-friendly context, when you see an acid as an electrolyte, one way that you can very easily identify it, it's going to be a covalent substance, and it's going to be listed on table K, right? Because table K tells you a whole pile of examples of acids. They're all covalent compounds because they're all made of all nonmetals, but they do have the capacity to break apart in solution to form that H plus that the Arrhenius definition says they'll make. So for example, let's take phosphoric acid, H3PO4. If we put that into water, we're going to get that phosphate, PO4 3- from table E, and we're going to have 3 hydrogen ions, so 3 H plus ions. So we've now dissolved H3PO4 and created 3 plus 1 mobile ions in solution. So that's going to be a very good electrolyte. Bases have similar easy rules to classify them as electrolytes. They're always going to be ionic, and that's important because you're going to see some organic compounds that we'll talk about later in the year. Those are not electrolytes because they aren't going to be able to break apart in the way that bases are. So they're ionic, and most of the time they're going to be on table L. There are at least 3 key examples of bases on table L that clearly show why they're electrolytes. So again, we can take maybe KOH and break it apart into the K plus ion and the OH minus ion. So we've created 2 mobile ions. We have ourselves an electrolyte. So those are true of all acids and all bases. They will break apart in solution and they will form mobile ions. So they are electrolytes. And just kind of as review, salts on table F, anything classified as soluble is going to be an electrolyte. So something like maybe, I don't know, NaNO3. If I dissolve that in water, that's going to break apart into my sodium ion, and then NO3-, which is the nitrate ion from table E. So again, we've created 2 mobile ions. Anytime we dissolve and form mobile ions, we've got ourselves an electrolyte. So overall, all electrolytes can be classified as either acids, bases, or salts. All acids are electrolytes, all bases are electrolytes, and all soluble salts are going to be electrolytes. The more ions you form, the stronger the electrolyte will be. So here we've got ourselves kind of a winner in terms of electrolyte strength, in that H3PO4 has the potential to be able to produce 4 mobile ions in solution if it breaks down fully. All right, so hopefully this helps ease our definition of what an electrolyte is and isn't. Yes, it's an acid. Yes, it can be a base. And yes, it can be a soluble salt.